Oh, man. Oh. It's like something.
Good morning. Yeah? Question? Preguntas? Yes, we are doing things today because we do not have time off. Okay, so today I need to show you guys voodoo. Love the voodoo. And then hopefully we will have time to do the other bizarre forms of integration that you've technically seen but you haven't seen like this yet. First, how about you sit with Stella so that you are not so close to the temptations of chatterness. So today we're going to learn how to undo product rule, which is not done in AV calculus or IBSL. Those of you who had seen calculus before, you probably don't know this. So, Ray, what is the product rule?
U prime times V plus D prime times U equals U over dx U.
Okay. Say it backwards for me and it distresses me, but that's not wrong, but I can't write it that way. I can just hear my calculus teacher say it differently. Okay, so there's product rule. And the V primes, that means derivative. So if I want to integrate this, Adrian, what's the integral of a derivative? Just the stuff inside, yeah. And then over here, I don't know, so integration by parts is this. Maybe I have a product of some stuff that U substitution, it's not working. You guys can look if you want to see. So if we have a product and it's not a nice like U sub kind of thing, maybe this is what we gotta do. Yeah,
How would you know it's like not a nice?
we're getting there. People are writing things, so I will wait. Okay. Flynn is here, Katie is here, Flair is here, Claudia is here, Julia is out sick still. Franco, Roman, Michael, Alex, Evie is back there. Cameron is in band. Evan is no está aquí. Kyle, Adrian, Kari, Ella, Jason, Sadie, Zach, Stella, George, Daniel, Sita, Naomi, Sebastian. Okay, so there's the pattern. And let's just see what's officially all the words under here. Yeah, So, all right, thought I had it written nicer. You just wrote it down, but the integral of uv prime I love these. This one is like one of my all-time favorites. So here's the little icon, and it's like the integral of u dv equals this thing. Looks like a tanning bed, but it's not. It's UV rays minus the integral of the voodoo doll. Voodoo, VDU, voodoo, get it? Ha! You're not digging it? Not a tanning bed, UV rays, UV minus the integral of VDU, which is voodoo. Get it? Stella, you're not amused. Gosh. Kids from college text me, hey, use voodoo today. Awkward. Okay, so here's the thing. How we choose the U and the V, Amelia, the U is something that's gotta differentiate to 0, probably. And the dV is something that's easy to integrate. Sine, e to the x, something like that. And here's an acronym that makes no sense at all, but how to choose the U value, lipid, look for logs first. If logs in there, that's your U value. Then, it's rare, but you might see inverse trig. And actually the way to do inverse trig and log, if there's nothing else there, you've got to use integration by parts. And then the more common ones, polynomials and exponentials, and then very last is trig. Jason, you should probably get a notebook out. You are going to need some of these on paper. Page. Here is our first example. So in this equation, this expression, x sine x, Nathaniel, do I have log anywhere? No, okay. Flynn, do I have inverse trig anywhere? No, okay. Ray, do I have a polynomial anywhere? Polynomial, do I have just x squared, x squared plus?
Yeah.
Yeah. So my u value is gonna be the x. So what is, and then the rest of this stuff is my dv. So Zach, what is the rest of the stuff? Sine x dx. Okay, so I need v and I need du. So Flair, in this example, what is du?
Just the derivative of x, so 1.
So 1 dx, sure. Claudia, what is the integral of positive sine x?
Positive cosine x. Negative.
Okay, so here's how it goes. This is that part. So now I've got things all neatly laid out and labeled. So Sadie, what is u times v given the setup that these guys just created? the integral of VDU, so Alex, what is VDU?
Cosine dx.
And negative, negative, I'm gonna make those positive. Abby, whose derivative is positive cosine? Positive sine? There's our answer. And if you're like me, I'd be like, that's a load of crap. I don't believe you. Well, I agree. So I'm gonna check myself, please, for the first time. Be like, this crazy voodoo really work? Sebastian, what is the derivative of this product?
So it's, -1 times cosine x plus -x times, negative sine x.
Okay. And Franco, what is the derivative of positive sine? Cosine? And, Sina, the derivative of C? Just zero, okay. So in here, now I have negative cosine x, positive cosine x, and then negative, negative. Is that what I started with? Oh, yeah. Voodoo works. So, the pattern, look for the U value. There's this acronym. Was there a log? No. Was there an inverse trig? No. Was there some kind of polynomial which could have just been x? It was hiding when you read. Yeah. So that's the U value. Everything else, that's gonna be the dV. Okay. And Amelia, in the beginning I said it's when there's a product and you don't like recognize what to do. That's when there's not even a product. But inverse trig and log, don't know how to do it without this method. So Michael, do I have log in the problem?
Yeah, like,
Yeah. So the U value is natural log of x, and the leftovers, there's nothing there. The leftovers dv equals dx, that's all I've got. Adrian, derivative of natural log of x. 1 over x dx, yep. Katie, the integral of dx. Integral.
Oh.
Integrating 1, I'm going to get 1 raised to the power from x to
Oh,
the 0.
x squared over.
X to the 1. So this was just 1, x to the 0. Raise the power from x to the 0 to x to the 1. I get that.
Oh.
Okay, and I didn't write the pattern down again. So the integral is uv minus v du. To put in the pieces together, Jason, what is uv?
X ln
X ln x minus, Sadie, what is the v du?
X, or it's just 1.
Okay, so she was about to say x times 1 over x dx. Oh wait, x times 1 over x is 1. Yeah, so just 1. Sebastian, what's my end answer?
So it's just x ln x minus x plus c.
Thank you. Plus c. Debbie, you okay? Craziness? Ray, you look like you have a question. Okay, no? There's nowhere to hide today. have 2 more examples to do. So you guys set it up. I don't wanna do it for you. What's your U value, what's your DV value? So it's your choice. Some people are doing different things with the 2. I kinda wrap the coefficients with that front polynomial, but you don't have to. You do have choices. And I don't wanna tell you what others do, but some others have a different method that is cleaner. However, there's a chance that you forget the 2 altogether and get the whole thing wrong. Integral of e to the x? E to the x. Okay. So uv minus the integral of v du. Did anyone read the title? How do I integrate that? Integration by parts, again. I mean, it's not hard, but boy, this is tedious. So putting the pieces together, that front piece is still there, minus parentheses, which are very much needed, uv minus vdu. Question?
The integral of 4e to the x is just 4e to the x.
Okay, I can move the 4 out front if you like. What's the integral of e to the x?
It's just e to the x.
And what happens with that 4? That's only because it was e to the x. Okay, there's one more style to show you. And next week, when the band people come back, we will do this problem again in a really fast, nice way. And this just unfair advantage. This here, this distributing these negatives, this was positive, then negative, then this switched to positive. So if I do this over and over again, the signs are gonna alternate, right? Like, because negative, then a negative negative became positive, then subtracted in. That'll be relevant on Monday. Okay. The last style. And Michael, you could sit next to Lily, so you don't have to keep like straining to
Yeah,
look
yeah.
around.
As well as yours to come late, but yeah.
The band people, chorus people, they're out. Jason, you gotta pick, what's our U value? E to the X? So, I got here UV, what's wrong? It would not be zero. Okay, so this thing looks familiar. Is that not what is on the other side? Oh, how about, here's the nasty trick. I call these the chase your own tail problems. I am gonna add this to the other side, so I have, don't know what it is, but I have two of them over here. And two of them equal this. Plus C. So what does one of them equal? That. So this is integration by parts. All of the forms. The ones that are repeated, the ones that are repeated and they come back and loop on themselves. By the way, those are all gonna be of the form exponential in trig. What do you think? see on the quiz next week. Technically seen them all, but I want to show you guys a few more of the amped up difficult stuff. Yes?
Are there any that just like keep looping and never come back themselves?
There's something, people, a lot of nerdy friends, they send me videos of things, and there's some that, they're called horseshoe problems, because they are their own integration, and they're big, crazy things. I didn't really pay attention to it, because I'm not that dorky. I'm not gonna spend my Saturdays like checking out math reels, despite however many ones you send me. But yeah, some spiral. Okay. We are not gonna do tabular today. And we'll save that one. But I want you to try this. This has a wrinkle to it that we need to address.
Good
Still
morning,
have 7
BCC. This
minutes.
is Dr. Mooney with a couple of important announcements regarding this morning's second period assembly. First of all, I want to make sure all teachers are aware there have been some adjustments to the attendance schedule, and teachers who were not previously on the list to attend should check their email for a message from Ms. Holland regarding which period they should attend. It is important for everyone to know that the auditorium will be full today, so we should be filling in every seat, and as students come in, they should move down toward the front of the auditorium and fill in. Staff will be there to assist with this. We should not be standing around waiting for friends or looking for places to sit, so fill in from the front of the auditorium. Also, for both assemblies, A and B, students should not bring their backpacks with them. We will return to second period at the end of the second assembly, so everyone can gather their materials. Students should begin reporting after the announcements this morning at the beginning of second period.
Okay, we still have 5 minutes. So separating the variables, I find it very hard to integrate this looking like that, so I'm gonna move it up by making the exponent negative. The integral of e to the stuff is e to the stuff divided by derivative of stuff. Cleaning this up some, I'm gonna multiply both sides by -2. You're right, I did not touch that unknown pile of stuff. Now it's -2 times an unknown pile of stuff. I don't need to keep it as -2 value. And my personal preference, I am gonna plug in the coordinate 0, -1 right now, because this is just looking like a mess. So -1 for y. So that's e squared equals c. That wasn't so hard. So e to the -2y equals -x squared plus e squared. I need to get y by itself. ln goes to the entire thing. Please note, no absolute value bars on the things on the right. I didn't integrate to get this. And now, and this wasn't the wrinkle that I was expecting, but, oh. There's the answer. Okay. these are long questions, they usually take a page to do, and it's really easy to drop a negative sign and make the problem not solvable, so be careful with that. Not yet. It says 8:20, not 8:16. Just looking at these. What does this one look like? R10. That one is also R10. So we'll deal with these on Monday because everybody needs to see these tricky things. We need to do some algebra with it first. What is this one? Arc sine. And so is this one. Good times. Again, we'll deal with them on